Hello, geometry students. Mr. Zacek back and better than ever here. We're looking in the second half of Unit 5, and we're going to talk about indirect proofs today. And this is a little different approach than direct proofs, which is what the majority of what we've been doing so far this year. And so when we do that, here's the steps. We'll begin with that way. The steps for writing an indirect proof. Number one, we're going to state as a temporary assumption the opposite or the negation of what you want to prove. And then we're going to show that this temporary assumption leads to a contradiction, and therefore the temporary assumption must be false and what you want must be true. So we're kind of like building a house, building an argument based off of one assumption. And when we find out that that assumption is incorrect, or that it contradicts something, then at that point we realize that our assumption is wrong, and therefore the other one must be true. So let me show you some examples of how we'll do this. Okay, so we'll still do statements and reasons here. And here's our, we can still start off with what we're given. And so in number one, I'm going to say triangle ABC is scalene. Number two, excuse me, the reason for that is given. All right, now here's how this is different. So in number two, we would say the opposite of what this is said. And so what we're trying to prove is that A, B, and C all have different measures. And let's say that angle A, angle B, and angle C all have the same measure. So that's the opposite. And so this is an assumption leading to a contradiction. So what happens here is, well, if angle A, B, and C all have the same measure, we could say that triangle ABC is equilateral. And the reason would be if all the angles are equal, then the triangle is equilateral. All right, now, why did we do that? Well, we did that because we're actually looking for a contradiction, but what do we see here? Triangle ABC is equilateral, triangle ABC is scalene. Those two things cannot exist. So once you have two statements that contradict each other, you found your contradiction. So all of this was built off of saying triangle A, B, and C all have the same measure. And so this is false. So therefore, angle A, angle B, and angle C all have different measures. And so the reason for that is a contradiction in statements 1 and 3. Okay, so the two new reasons that you're going to use for this are found here: an assumption leading to a contradiction, and a contradiction in statements. And that will change the number of the statements, but that's kind of the idea here of how we do this. So this is an indicator to use an indirect method. When you see that something is saying try to prove that something is not true. When you see that, that's kind of telling you, oh, that means we should be thinking about an indirect method of proof. So let's start off here, and again, we'll start off with our given that triangle RST, that angle R is not congruent to angle T. Okay, that's given. All right, so step 2, we're going to assume the opposite. Or another word for that is the negation in logic terms. So we're going to assume that RS is in fact congruent to ST. So that is this reason, an assumption leading to a contradiction. Contradiction. So if that's the case, if RS is in fact congruent to ST, then what kind of triangle is that? Well, that would mean that angle R and angle T are congruent. So if we're going to make that statement, the statement we made in number 2, in 3 we could say angle R is congruent to angle T. And the reason is, if two sides of a triangle are congruent, then the two angles opposite those sides are also congruent. Okay, well, both of them cannot be true. So here's what we're looking at. This is what we were given as true, and this is what we could say as true, but we could only say that because we made this assumption in statement 2. And so we have a contradiction. So therefore, we can now say that RS is not congruent to ST. And the reason was a contradiction in statements 1 and 3. So, to review the process, you assume the opposite of what you're trying to prove, and then you build an argument looking for a contradiction. When you find a contradictory statement, usually it's going to contradict something that we're given. Therefore, our assumption has to be false, and the opposite of it must be true. All right, so let's try a couple more. All right, so we want to, let me just write this out here. Okay, so we're given that angle 1 is not congruent to angle 3. All right, that's our given. So we're going to assume the opposite of what we're trying to prove. Angle 2 is congruent to angle 4. Okay, and this is an assumption leading to a contradiction. All right, well, if we assume that 2 and 4 are congruent, 2 and 4 are alternate interior angles. So we could then say that M is parallel to N. If two lines are cut by a transversal, such that alternate interior angles are congruent, then they are parallel. Okay, Well, if that's the case, what could we say about 1 and 3? Well, if the lines are parallel, then that would allow us to say that angle 1 and angle 3 are congruent. And the reason would be if two lines are cut by a transversal, and parallel, then alternate exterior angles are congruent. Okay, well, hang on. We got ourselves a problem here because in step 4 we're saying 1 and 3 are congruent, and in step 1 we said that they're not congruent. And so we have a contradiction, meaning they both can't be true. And it's built off of saying that 2 was congruent to 4, that assumption. So our assumption is wrong, and therefore angle 2 is not congruent to angle 4, and it's a contradiction in statements 1 and 4. Okay, we've got one more. So given MO congruent to ON, all right, so MO congruent to ON, and we have something that's not true, we're going to try and prove this angles are not congruent. So again, the indication for this here, the way that we see an indirect proof method is by when we see that the thing we're being asked to prove, oftentimes it has that not through it, the little slash that means not. So let's assume the opposite. So angle MOP is congruent to angle NOP, all right, and that's, okay, an assumption leading to a contradiction. All right, so I'm assuming that. So MOP, that's this angle up here, and NOP, that would be this angle. Well, what else do we have here? We could say that OP is congruent to OP by the reflexive property. And then with those things, now we could actually say that those triangles are congruent, you know, based off of that assumption. So triangle MOP is congruent to triangle NOP, and the reason for that would be side angle side, congruent to side angle side. Well, if those two triangles are congruent, then what we would then be able to say is that MP is congruent to NP because corresponding parts of congruent triangles are congruent. And what did we just do? We just found ourselves a contradiction between something that we were given and something that we proved, but our proof was based off of an assumption, and therefore our assumption is wrong. So angle MOP is not congruent to angle NOP, okay? And the reason is a contradiction in statements 1 and 5. So it's not as major of a topic for indirect proofs, but it is something that's included in our standards, and so I want to present it to you. You know, you can kind of think about it like it's a little bit of like trying to catch somebody in a lie when you know they're not giving you the truth in a situation. If you can set something up where you get that contradiction, then you know that what they told you was not true. All right, so if you have questions about that, let's ask those in class, and I've got some assignments to give you some practice with this one. Good luck. See you soon.